Okay, so welcome everyone. As Mark mentioned, George and I are going to be talking about roles and responsibilities in Fabric. Before we do introductions, just my thoughts on Fabric is it's the consolidation of a lot of existing technologies like Azure technologies that you may be familiar with, all packaged in a pricing model and in a kind of Power BI workspace kind of looking delivery. And what we're going to talk about is we're going to identify the different size projects and what the roles might look like in each type of project. And yeah, it'll be a mix of it's a lot of just about the people and what they do, and as the project size grows larger, what the roles look like. But jumping ahead to us, so I'll say a little bit of something about myself, and then George will jump in and give a little something about himself. I've been with DesignMind for 7 years. I think when I joined, Power BI was really just kind of taking off. We did these dashboard in a day events and did a lot of Power BI projects. And then I would say probably for the past 5 years, I've been primarily doing data engineering in Azure Databricks and all the Azure kind of lakehouse technologies, Data Factory and Azure Storage, and Databricks being the primary ones. But yeah, like George, I'm experienced end to end in all aspects of BI development. Over to you, George.
All right. So welcome everyone. So my name is George Vasiliev. So today I'm happy to present this presentation together with James. So about myself. So I've been like for many years in data. That's kind of my main the profession. So and mostly coming from the like big corporations, industries, like working on a large solution, and mostly those are data warehousing world and BI world. So I've been like multiple years with Microsoft at different roles, like engineer, like data engineer, data architect, as well as like technical program manager. And most of the kind of looking forward to what I like to working with data and making like packaging data as a product, which is right now there are more and more world depends on the data and relies on the data. So data becomes a product, and there's all of the aspects around this, how to manage data, how to process data, how to sell the data, how to price the data. So that's and what the value of the data, how to reveal all of the value. So that's kind of my main topic, even like kind of outside of my professional work. So here and so that's quickly about myself. I'm in Seattle area, so a little bit kind of away from California, where the most of the people in. Yeah, but anyway, happy.
All right. I was just going to add one more thing, and then George, we can go into the next slides. But George and I have been working together for maybe 4 months now.
Yeah. I think
April, something like that.
Yeah, April. Yeah, May. Yeah.
So we are platform architects on a large client of ours, and the roles and responsibilities that we're going to walk through are representative of what we have on our current project. So this will be a natural conversation for us.
And then I'll go forward with this one, right? So as James mentioned, so here like the mostly in this deck we'll go over the key roles that usually comes in the data projects, and right now this will be connected to Microsoft Fabric data project because we'll be referring to the artifacts, specific tools, specific like elements of the fabric. So that for the people who already had been working, and majority of the people here had been working already with the data projects, so are familiar with those roles, and that will kind of focus how they are connected together, what their main goals and focus, what their main scope, and how they collaborate together. And especially this is like with the Microsoft Fabric as the platform for data integration. Go next slide. So here, like, because there are different projects, and the Fabric is really the product that can work in a different scale of the company size, of the project size, of the implementation size. So we kind of divide here as a kind of on three groups of this project based on the size. So this particular talk today mostly about the medium scale and large scale, because here, like if we're talking about the small scale, it's like 1-2 developers, and this is usually, I know, within like one little department, and there's not really clearly separation of those roles here. So that's why kind of we, for this presentation, for example, we start kind of focusing on the project, which is like medium size, where we have like clearly like project manager, we have like architect, developer, report developers, like BI developers that are clearly identified there. And there may be like one person or maybe a few person of engineers, as well as like large project scale is like we're gonna think this is like 6+ people working on the same project, and that's even more interesting, like how the work is circulating around those people. So those projects can be like here, like will be like that will be shared after for takeout, but here like we can identify based on the number of people, and those are some elements of the size of the project. Usually it comes with this, like on the infrastructure, the data volume, and like kind of key functionality, their key feature within this Fabric infrastructure. Yep, so let's go next slide.
Right. Team structure.
Yeah, team structure. Okay, coming back here. So like in this presentation, we will discuss this 5 roles, like project manager, which is like, I mean, it can be like in some big project can be absolutely different roles and different people. Here, let's combine them together: project manager, platform architect, data engineer, developer, like report developer, BI developer, and data scientist, if data science exists, or maybe sometimes like kind of BI developer and data science all together. It depends on the skill set. And let's go jump to the first one.
Yeah.
The product.
I would add one point in here, and Georgia and I didn't discuss this, but these are distinct responsibilities, and we have it carved out here as it's different people, but budget is a concern. And what I would say about that is, let's say that a company only had budget for one person or 2 people. These are how I would think about the kind of tasks that we would be doing, right? There would be platform architecture work, data engineering work, report development work, maybe data science work. Could be all one person, right? So I'm just going to point that out. It doesn't change our talk at all, but these are like distinct areas that have a lot of skills that George will get into.
Yeah, plus Fabric itself, like the tool set, whatever the artifacts that comes there, that really have these certain tool sets that really dedicated to certain roles, and that's kind of clearly says there on the overall architecture design there. So starting with the product and project manager, so those are a combined role, and this is leading role for kind of understand the project goals really, and have communication with the client and who this users, define the project goals, the priorities of those goals and deliverables, the timeline, and what milestones needs to be put there in order to deliver the results. And also that will be like a different way. So there can be, some of them can start with like POC, proof of concept, MVP, and that can be like agile process where like features will be added one by one, tested, deployed to production, the new feature, or maybe that will be like big scoped project with the more kind of waterfall approach, where there's like big scope is defined and there's a timeline, there's a budget, and then we need to, okay, we kind of work 6 months and we deliver this. Then next 6 months we deliver this. So those, and the product manager is the person who is like really need to make sure that this is well coordinated with the customer, and this is like well aligned, and this is part of the plan. Then kind of another like stakeholder communication and team coordination. So also like manage requirements, manage all of those, making sure that those requirements are really well captured and they aligned with the goals. So making sure that for all of the milestones we have clear set of requirements, there's no ambiguity there, and the people, the rest of the team, have really have their input and they have all the kind of questions answered there, so they are not blocked. Then at the same time, go to risk and resource management. So when the project going, so when the like on the planning phase, like we need to understand like what kind of risk possible there. Maybe there is maybe kind of risk identified technical risk. Maybe the technology is still in development there, so we need to have some workaround there, or maybe have some kind of more simple solution, and then like until when the kind of feature will be delivered in the future and more tested by Microsoft, then in this case we can switch to kind of implement another way. So also the resource management, making sure that we don't have bottlenecks there, the people not burned out, and they kind of we deliver as based on schedule. And also here, like always, have the define the communication between the development team, because like entire team, and between the users, between the customers here. So making sure that this like the feedback is captured always, the feedback is delivered, there is the proper like user acceptance testing and testing validation done with collaboration with the customer, and as well as like visualization and the managing the communicating the progress, communicating the issues. And that's most of the kind of work on the project manager. So let's go next slide. And here, like, so all of these roles will have like a kind of 2 slides. One slide is generally describes what the person is doing, and the next slide is more kind of takeout slide with like kind of area of expertise and maybe some kind of skills, list of the skills that usually people need to have in order to take this role. Maybe this is not completely.
George and I were saying it when we were putting this like second slide deck together. This is almost like you could take this and this is what you would go hire someone for, right? Like these are their job description. It's almost like a job description kind of layout, but
yeah. All right. Yeah, here like here you can see like this is mostly resonated like the areas of expertise with the previous slides. I would like to highlight here there's like the most important here that a product and project manager really need to understand the platform itself component, not very like no need to be developer there, but in order to understand like how platform works, what the components available, what those components, how they are connected to each other, how they what the value they deliver. So and kind of need to really understand like all of this, and also like technical skills, how this is integrated.
Yeah.
And be always, and I would say like probably always communicating with the architect, making sure that kind of the person is learning always, and not like kind of go deep to the technical, but and understand like overall how the process, how the product, because eventually this is the platform will deliver the product. Also, like part of this, like SDLC, like software development lifecycle, release process, those are also like making sure that a person is well aware of this and help to doing all of this process to deliver to the production and to testing. Yeah. Okay. So
I would add. Let me just add one thing here. I like what you were saying about how they really need to understand the product, but I want to clarify when George is saying product, on these large projects, we're building essentially like a framework, right? A framework that does stuff. And you feed the framework configuration details. But the framework sometimes needs enhancements for new functionality, right? So it's like it's a product in that sense, right? It's a product that can
Yep.
handle all the aspects of BI. But then there's the other side, which is the customer delivery, which we'll talk about, which is the like the report developer. And a lot of times the project manager really just understands like the business user and the report they want, and then they dish out the work. But a really great product manager realizes that like there's the forward facing stuff and then there's the back end stuff. And it's balancing both. And when George is talking about features and how things work, a good project manager actually should be knowledgeable in not just what the customer wants, but also what the engineering team is building and this framework and platform that we're building for the customer. So
Yep, absolutely. Yeah, thank you. And and this is
yeah.
because there is the maintenance needs to be done when the system is in working place, and there's making sure that there is like the client they need to handle this, and this is like packaged as a product. All
All
right,
right.
yeah, let's go to the next
All
one.
right.
Yeah,
All
James.
right, so I'll do this one. All right, so platform architect. Um, all right, I'll kind of go through each one of these. So infrastructure design and management. So again, this is that product that we're building that we don't have a bit on this in our slide deck, but the you might have heard of this medallion architecture, bronze, silver, gold layers. That terminology is, that I think Databricks made that kind of terminology popular. But really, on our project that we're working on, we call those three layers raw, stage, and model. But it's this layered approach, right? So then it's like, how do you achieve that? And how do you avoid people building, I call it artifact sprawl. How do you have organization, and what does organization mean? So there's design, there's governance and compliance. So this is platform architect has a deep understanding of the technology, has I'll call it first time design patterns. So there'll be an area, and the architect will uh, create the design pattern and communicate that to engineers. So governance and compliance, integration with external systems, right? So what we try to do is build a generic framework. So we will make a statement. Our framework will handle any SQL Server database. You just have to send it configuration details. Our framework will handle any Oracle database. And it will handle full and incremental refreshes from those relational databases. But then we have REST APIs, right? So every data provider that provides data through REST APIs has like like varying implementations, right? So a lot of times we'll look at that as generic in the sense of, okay, we can pull data from HubSpot or we can pull data from Salesforce. Um, Whereas the database stuff could be totally different ERP systems on SQL Server, but it's this goal to tackle an integration with a data provider, and the architect goal is to minimize artifacts, focus on reusability, reusable components that are highly parameterized and configuration driven. When I first started working in Fabric, I put some links down here at the bottom, but there's a great article on the title's called Meta-Driven Pipelines. How the guy implemented it specifically isn't so important, but the idea is what's important, right? That like you have these generic components and you feed them configurations. So what about Fabric? So Fabric has all these technologies that, as I mentioned earlier, you might have worked with before. You might have worked with Azure Data Factory in the past 10, 15 years, right? Um, there are now Fabric pipelines offered. So this is, you do new pipeline. You can chain pipelines together. You can call notebooks from pipelines. And there's a fairly close one-to-one activity mapping between what's available in Data Factory and what's available in pipeline. I would say in general, Fabric is a bit watered down version of all these other things, right? So by that I mean Fabric Pipelines does not have all the activities that Data Factory has. Fabric Pipelines cannot be fully parameterized like Data Factory can, right? Data Factory, you can parameterize all your link services. Not so elegant in Fabric. Databricks. So Databricks runs on Spark. Fabric supports Spark, runs on Spark. Notebooks leverage Spark clusters. This is pretty full-featured. It is. Azure Storage versus Fabric Lakehouse. Azure Storage is a much more mature product. By mature, I mean there's very granular security. There's tight integration with auditing and data retention and all kinds of things that are getting phased into lakehouses right now, right? So there's Fabric lakehouses have a table component and a file component. So the lakehouse file component is kind of the Azure Storage equivalent. Azure SQL, there are Fabric warehouse. There is a concept of a Fabric warehouse. On our project, we've decided not to go with this. Kind of the feedback, and this is just, not official or anything. This is just like what I've noticed is that there's not a lot of attention on Fabric warehouses. And kind of when you read up on it and why you'd use it over just Delta tables, it's not really a great story. And source control integration is not there with warehouses. A merge statement last time I tried in April was not supported in Fabric warehouses, and it's like, okay, they have it, but we're not using it. We're using lakehouses and Delta tables, Parquet, back Delta tables. Key Vault's a robust product. I'm sure you've used that on all your projects for storing secrets securely. Fabric offers something called Fabric Connections, and Fabric Connections is kind of half-baked. Yes, it stores, you can enter credentials, but you don't have, you don't have the same level of control you have with Key Vault. All right, so one last thing on the architect and what the architect's doing and what can be done in Fabric. So having done lots of projects in Databricks or in other tool sets, you need a framework. You need to build a framework. And the reason for that is you need to establish patterns for other people to follow. And you want to create reusable components. So you need some kind of configuration framework. For us, we had each layer of the architecture, we came up with a JSON schema for that layer, right? So the raw layer is our data sources. Came up with a JSON schema for that layer. Stage layer came up with a schema with that. Model layer we have consists of like 3 components. The object itself, which could be a dimension or a fact, a group, right? You need to refresh to, like, there can be dependencies, right? Like you need to refresh at a basic level, you need to refresh all your dimensions before you refresh your facts, right? So you need at least minimum of 2 groups, right? So underneath within each group, you have your model object. And then what we did on this project is in our JSON schema, we have all of the stage layer dependencies for the model object. So let's say we have a dimension called company, and we have 3 systems that have company. We list the 3 stage tables where we source that information. The point is that you need to build a configuration framework. You need to have an auditing framework, right? So that you can monitor and understand what's going on. Yeah, there's like a whole framework mindset that you need that a traditional data engineer may not know, right? A data engineer might know how to do a data flow. They might know how to do a pipeline, but it's a little bit higher level thinking that the architect does. I would say the architect role, the 2 things I would add on architect role. Number one is like if you've got a large project, you're going to need an architect, right? The question is, how long do you need an architect for? You need the architect to build out the framework. After that, it should be handed off and someone takes over the managing of it. Not all companies want to do that and they keep architects on for longer. Um, but at a certain point, you can almost think of it as like, okay, it gets handed off to data engineers, right? Data engineers can maintain and keep the framework going. They can add new data sources. They can do all kinds of stuff because the patterns are in place. Another way to look at this is like when like a company like DesignMind might have a framework and you've got a large fabric project. Well, then it's not an architect for a very long time, right? It's an architect to, again, bring maybe the framework over, train and teach engineers how to use it, and then they're on the project in even shorter amount of time. But the having a solid architecture is really important. And what I would say is that if you just opened up Fabric and you learned all the components in Fabric, doesn't necessarily make you an architect. It makes you just maybe an engineer who's familiar with all of the Fabric components. But there's just like a little bit of higher level thinking that the architect role
Yeah,
takes on.
and there is like maybe I'll add on top of this on the architect. So there is like also and remember like that there's like all of those components in a fabric, they under one roof of capacity. There is one dedicated computer resource used for the compute all of those components. Like when you run the notebooks, when you query the data, when you run the pipelines, everything capacity. So like one of those like roles of the architect also envision the and understand the size of the system, the usage of the system, the making sure that the capacity doesn't run out. So like we
Yeah.
had like situation we started like what is like F-16, and then we
Mm.
did like excessive like development testing running pipelines, and then like in the middle of the day we realized we can't run the query. We
Yeah,
completely
yeah.
exhausted. Yeah, and then like well luckily
Nah.
we have like trial subscription. I mean trial, we switch to trial and we continue our
Yeah.
work. Yeah, but
Yeah.
that kind of making sure that also like architect is really understand the amount of compute that's going to happen there. Plus, also there's another aspect of the data governance, like making sure like data retention there is well kept, like all of because those parquet files, which is like delta files that are generated there, they sit there forever in the storage and they will pile up a storage and eventually they will kind of eat up the storage. Even the storage is like kind of unlimited, but client will pay for this, right? So there's making sure like when there's a proper data retention on the on those like and like data hygiene procedures there uh, set on the all of the tables, files and everything there. So those are also like kind of architect needs to think about this as well. So making
Yeah.
sure this is part of the all of the framework and the kind of long-term planning.
Yeah,
Uh,
I like that you brought up the resource usage because one of the at the end of our deck, I'm going to show something I came across that really reduced how much uh, compute we were using, and it has to do with
mhm.
running things in parallel, right? So so it's a later slide. We'll get
Yeah.
to that,
Okay.
but we can
Or
jump into the George. You can take over and talk about the data
okay.
engineer.
All right. Yeah. So the data engineer. So data engineer is this. They will work really closely with the data architect. So they mostly this is the person who is writing the code, making things happen. And as so again here, like most of this, the person needs to be really well familiar with all of those components, how they work, and how they are programmed, like whether it's a data pipeline, whether it's like notebooks, how those everything works. So this at the same time, they because this is data engineering, so it needs to really understand overall kind of principle and technique best practices of the ETL or ELT process. So how like also this is very involved like the data modeling things, like data transformation, how like all of the like enrichments and additional like fields, attributes needs to be added on every stage when we transform the data in
Mhm.
order to make sure like the framework is working, whatever the framework is set up as architect. So the automation of the like what kind of tools of automation available there, how to automate this, how also like making sure like all of those components, they're really kind of well parameterized, they're reusable, they're not like, yeah, because like when you have something like a pattern there, then making sure that there is a proper the parameters passed there if this component needs to be parameterized and be reusable. So
Yeah.
this is as well like
So
making sure like
I'll give a
yeah.
simple, Jordan, sorry to interrupt, but I'll give you a simple example. A simple example of like something that like a novice data engineer might do is they'll go into Data Factory and let's say there's 25 SQL Server tables that they want to land to Data Lake. They'll build 25 different pipelines, right? One for each table that lands the data. And then an architect would look at that and cringe and create, create one pipeline with a parameter for server, database, schema, and object. And then that he would create some kind of configuration area and feed the configuration through that one pipeline. So that when George says reusability, that's like a simple real world example. Yeah.
Yeah. And plus all of the important very component, because every component need to have a log, like whatever happening. So making sure that the logs are done, whether it's like there is some enable standard log, which is right now, it's kind of very early stage when the log analytics you can connect to the fabric. Like for example, like in Data Factory, you can connect log analytics and you can kind of feed all of the events that happens in Data Factory, feed the log analytics. And then there you can observe there's like using the Gusto query language there to run the to extract the logs and analyze the log. The same here, like but right now, like it's very early stage and we're kind of still exploring that feature. But at the same time, if it doesn't exist, you need to have your custom like audit
Auditing
and log.
framework.
Yeah,
Yeah, yeah.
like
So
audit and
imagine
log,
in
like
that
make sure the logs are
that's a
there.
good point. In that example where I said where this like kind of the novice data engineer creates the 20 pipelines, then they start copying and pasting all the auditing components. So this is it's the data copy, but then they're like putting in all the logic for auditing and they're copying and paste that in every pipeline. So just in general, is when you copy and paste is not okay in data engineering.
Yeah.
As soon as you're copying and pasting something, it should trigger that, okay, we
Yeah.
need a pattern here. And either the data engineer can create the pattern, or in the absence of an architect, or the engineer should bubble that up to the architect and say, hey, I'm doing a lot of copying and pasting. This doesn't seem right.
Yeah.
How do we make this reusable? Yeah.
Absolutely. Let's go to the next slide.
Okay.
Right. So again, like here, this job description.
Yeah.
Okay. So yeah, here, like, yeah, on the right side, you can see like there is a list of the technologies. Pretty much, they are mostly kind of aligned with this with the like architect that was before there, because then this is the same technology stack. And this is the more the person needs to be, yeah, hands-on on the like development. And mostly like in Fabric, mostly there is like two things there, the Python and SQL. That's kind of mostly kind of you can run. I mean, like you use Python to manage process, and then you use SQL to query data, to access data.
Yeah.
Those are combining those two together, and even like all of the notebooks there, that's kind of the combination of those things together.
Yeah, a
Yeah.
common pattern that we do is we'll have Python code that will dynamically build SQL, right? So you need Python to dynamically build the SQL, but then at the end of the day, you're executing the SQL to retrieve results from the
Yeah.
lakehouse or the database.
Yeah,
Yeah.
yeah, and the SQL is there. It's interesting. Like there is a different flavors of SQL. Even like when you run this Spark
Mm.
SQL, there is a one flavor of SQL. There's a certain set of functions, internal functions, command there, and then you query data with the SQL endpoint. This is like Microsoft SQL. All of the functions that
Yeah.
you have MS SQL. So that's kind of, and that's where we have like I mean, you see, it's interesting, like we use in order to, when we need to kind of, for example, drafting the code in SQL Management Studio. So, and then I need to convert to Spark SQL. What I do, I use ChatGPT. I have it a query. Hey, can you convert the PySpark?
T-SQL to
Yeah,
PySpark. Yeah.
that is, yeah, Spark SQL.
Spark. Yeah.
It's doing a great job there. So there's majority of those formatting, SQL formatting is really done. So and like yeah, kind of feel free to use like most of those like kind of generative AI tools to help you to do with a lot of kind of routine coding, typing, all of the stuff. So that's kind of really good.
Yeah. I'm going to point out one thing, and that's that we have modeling under data engineer and not under the report developer, which might be weird for people, right? And I put that on the data engineer slide, and really every every report developer should have strong modeling experience. They should know about dimensions and facts. There is a level of complexity, though, that you hit when you try to just do that stuff in Power BI. And really, on these large projects, we have there's two models. There's the data warehouse model, so dimensions and facts, right? These are tables that we populate, either full refresh or incremental refresh. Maybe the dimension tables are SCD, type 2 tables. And that's warehouse stuff. And the engineer is better suited for the data warehouse stuff. Where the BI person comes in, which I'll talk about in the next slide, is the semantic model. And the semantic model is where you take those warehouse dimensions and facts and relate them and things like that. But that's why we have modeling on this data engineer role.
Yeah, and here I would also add here, like there's number 7 here, because like the engineer doesn't really only work with within this like fabric, but it also the most important to have the to establish right connection to the different data source. And fabric allows to integration to multiple different sources, data source. There's a bunch of databases that are connection, REST API, streaming data. You work with the file storages, like I mean even like you work with the file storages like on the in a lake. You can work with file storages well, like when like the AWS. You can work with the SharePoint files. There's like so there's also up to so the engineer needs to be proficient with working with those different data sources, handling like kind of querying this data and see how each connection works.
Yeah,
efficient. So that's also kind of one of the.
A data engineer working in Fabric should absolutely know Spark, should absolutely know how to write Python code, work with REST APIs, and have an understanding of just data lakes in general and why it's important to have them well structured. And bonus is modeling, right? And that's why I said I pointed that out as a weird one, right? Because you could interview 100 data engineers and they may have zero knowledge of data warehousing practices, right? So it's like kind of I think it's important in Fabric. It's really important in our current project, but that's often data engineers like I wouldn't say that they understand like dimension and fact concepts. It's more of a BI concept. But anyway, that's that on that. I'm gonna jump over to what is it, 750? It's like 750 already. So
let's maybe kind of a little bit speed up, yeah.
All right, so we all know what report developers are. I have high standards for this, right? I would love a report developer to have an understanding of dimensional modeling. Ideally, I would like a report developer that doesn't just create one wide result set and just drag and drop fields on a report. They would understand the advantages of having dimensions, right? And another high standard thing for a report developer for me is knowledge of tabular editor. There's a screenshot of tabular editor scripting window. I'll share a real world experience I had with this, and I did a demo for a few people recently. Tabular editor, you can connect to a Power BI model. You can also connect to a Fabric semantic model. Fabric semantic model we've been playing around with. You create it in Fabric. It lives in Fabric. You can connect Tabular Editor to it in Fabric. And one of the cool things it does is it supports something called Direct Lake. Direct Lake, so if you're familiar with Power BI, there's import mode, direct query mode, there's live connect to other data sets. And now there's a fourth connection type called Direct Lake, which eliminates the need for data refreshes in reports. You point to your Fabric Lakehouse tables, and the data is always current. But from what I've seen, you need to create your semantic model in Fabric. The UI is a little limited, and Tabular Editor fills in the gaps. But the cool share I did the other day was the power of Copilot. I use Bing Copilot. I don't pay for ChatGPT. I'm pretty happy with the free Copilot. But I went into Copilot and I said, generate a C# script that I can use in Tabular Editor that hides the visibility on any column that starts with the word amount, hides the visibility, create a measure for that same column name with space total at the end, and create DAX that says, that just does a basic summarization, and format it with this string, blah, blah, blah. It generated a perfect C# script that I pasted into this scripting window in Tabular Editor. I clicked play, and it went through all of our fact tables and did that. Other uses for it, search for all dates and format them with this format string. All kinds of things you can do through Tabular Editor scripting. So high standards for report developer, understanding dimensional modeling, but also understanding the power of some of these tools that are out there that like maybe the average Power BI person doesn't use. Yeah, so in terms of the resume for them, right? Like, yeah, they should be familiar with semantic models. They should be studying up on what's possible in Fabric, and obviously an understanding of Power BI models. They should be familiar with Power Query, although, I don't like using a lot of Power Query in reports, right? The data warehouse object should be pretty good to work with, not too much transformation required.
Yep.
DAX, big topic, row level security, things like that. The Power BI stuff is pretty straightforward, but there's a lot of Power BI developers out there, varying skill sets. All right, George is going to say a little something about data science.
Yeah, a little bit on data science. So good thing that like Fabric has the tools for like data science. It's not very advanced, but at least like there's the basic stuff. You can first of all you have your Python notebooks where you can connect any kind of libraries there, whatever available in Python. There's a lot of them, so you can run your data experimentation there. You can create run experiment with the data, create the models from those, which is like separate components there in Fabric, and then you can apply those. You can incorporate those models, you can train the models, and then you can connect those models to your data sets. So you can integrate the models to data sets. Also, so that's mostly about this is like ML ops routine that usually data science doing. Also, at the same time, there is tools there for data exploration and understanding the pattern. There is when you are in the notebook, there is a tool there that allows to work with called data wrangling. So once you put your data sets in the data frame, so it gives you different kind of things you can kind of play with the data set and data frame and quickly apply certain filter and transformation there, observation there. So those are also kind of good to
I
have
haven't
this.
used that much. Data Wrangler is available in notebooks. It's a way of it's a UI for saying what you want to, how you want to clean up the data.
Yeah.
And then it's a code generator. It's like it's a UI that in the background generates code.
Yeah.
Plus
also
for
like
cleaning
all of
up
this,
data.
all of this, the new stuff with the Copilot on top of Notebook. There's also interesting things there. I mean, they're still kind of in development and preview, but there's also a lot of things that can be automated there for data exploration, analysis, and also important here. This the data science is really kind of working with the business stakeholder and making sure there is really clear understanding. On one side, it's very well collaboration with the data team, with the rest of the data architect, data engineers, what they do, what kind of data available in the system, make sure that what kind of data modeled there, and at the same time cooperation with the stakeholders and making sure there's a tasks there, whatever tasks outside of the just data transformation, data handling, what kind of the business task needs to be handled by the data science, what kind of discovery needs to be done, what kind of the machine learning models needs to be applied. And this becomes like also there will be from data science becomes like additional input to the team, what kind of requirements, technical requirements to the data needs to be done in order to fulfill those models. So there's like
But
very
yeah,
cool,
what I would add
clear
is, yeah,
cooperation.
like everything we're discussing all lives in a Fabric workspace. Fabric workspaces can be tied to Git for source control, and then as platform architects, we have to coordinate how all these things get deployed. So data science is just, it's not like a team using one-off tools anymore. It's all part of the Fabric platform.
Yeah, and then later, like here, like we can talk about the collaboration. How like what the tools available and what the kind of artifacts for collaborating. And this is like again, this is kind of our observation. This is our proposal. There may be not all of them, but this is what so far.
Because we're short on time, I'm gonna
yeah.
I think
I'll go
this is a
quickly.
really powerful one that, I mean, I could chat about this one for a sec.
Okay.
So what this has to do is how we organized our workspaces in Fabric, and you might find this really useful. And we had many iterations of this. So in the brackets where it's env, that's environment. So imagine dev, UAT, prod, right? Maybe more. And then what we call it after that, right? So engineering. These are all our generic stuff. Like this is our framework, right? And the framework has a configuration concept, a job concept, auditing concept, generic pipelines and notebooks, and everything's source control. The data workspace has this is the business data, right? So like the engineering stuff, our configuration, our jobs, and all this stuff, it's really processing data that we decided to keep in a separate workspace. And the reason for that is like, the permissioning in Fabric it's still being developed and stuff, and it's not as like fine-grained control as we'd like. And really, we don't need anybody in our engineering workspace at all, right? But people need to work with data. So, you know, all right, so it's data science. Data science they go crazy in creating artifacts and everything. And a lot of times they're just trying to hack away and create stuff that works. And maybe they are taking data from our bronze layer. Maybe they're taking it from our gold layer. And they're kind of doing their own stuff to shape the data the way they need it. So they might have a lake house of their own. They might have tables of their own. They might have pipelines of their own. They, they might have experiments, all this stuff. They've got a lot of artifacts that we didn't want to clutter with our engineering workspace, which is very clean, our data workspace, which is very clean. We wanted a dedicated space for data science. Analytics, one of the lessons learned with this is, especially if you're using deployment pipelines, if you have a Fabric semantic model and then you have Fabric Power BI reports pointed to that semantic model and you want to use deployment pipelines, these two currently need to live in the same workspace. I'm sure they'll get around that at some point. But when we had our semantic model in engineering and then we had our reports in analytics, deployment pipelines didn't work. But all of these things are source controlled. The final one we did is there are many times where developers, like architects, data engineers, even our Power BI people who we say, hey, there's data available here. We want them to be able to run queries and stuff and have notebooks. We have this like dev scratch environment, and it's not under source control. And people can create whatever they want. It's just a dumping ground. You can create a notebook, you can query tables, you can do whatever you want. You can, in your notebook, you can add a lake house, right? You add a lake house from here to your notebook here, and you can work with the data across workspaces, right? But anyway, there was a lot of a lot of this was like a changing structure for a long time as we were learning Fabric, but this is what we ended up with. You
Yeah.
might find that useful.
One of the point here, like, can you scroll back here?
Oh,
So there's
yeah.
like, you can do, for example, for data science, because you can do shortcuts across multiple, like, I know from the lake house to the lake house, shortcuts. So that's
Mhm.
kind of, you do need to even copy files because everything, all of those like data is sitting on the same storage. And here, for example, data science, they have their own lake house for kind of sandbox experimentation. And you can kind of link there to kind of multiple tables as a shortcut files or something, plus have their own like tables that run there. And then once they run experiment, then basically those experiment maybe become part of the input for the architect and engineer. Hey, this needs to be implemented in kind of
Yeah.
in engineering space. So those are kind of
That's a great example,
extra.
George. So like in
Yeah.
this scratch area, someone could create their own lake house called the James Lake House, and I could add a shortcut to a table from the bronze layer. I could add like 5 shortcuts to different model tables I need, and I can mix and match and have my own little thing here to write queries with. It's a good point without
Yep.
the burden of physically copying data. Yeah,
Yep.
good point.
And
Right.
all right, so here quickly, like we'll go like quickly on the this call it collaboration helpers, and those are really a few elements that kind of become really really useful, and they need to be established in the very beginning of the project. So a few of those like data dictionary. So data dictionary, this is like where the especially when there is a modeling the exercise happening, when there's model data modeling activity happen, when you kind of integrate everything and create from different sources and create a model. So that's kind of where everything needs to be documented. And it's not only even documented at the very end, but during the collaboration together within the team, then what kind of columns, what kind of tables, what kind of source to target mapping needs to be done. So that's kind of the reference points. And that
Yeah.
also, so this serves internally as well as serves for the users in the future.
George, I'm gonna jump
Yeah.
over just to the example of the data dictionary.
Yeah.
And
Uh,
it is really tiny. How do I zoom?
I mean,
Well,
yeah, I
but
mean, yeah, generally this is shows like source to target mapping. Like this is blue column here. It's like really target columns that will be in a table, and you can see this is like dim project
yeah,
table, the dimension project. And here, like on the right side, you can have like the sources like IFS, the retech hub. So those are really different sources from different systems, and how
yeah,
this data is from different systems, how they merge based on the logic, which columns map to the final column in a DIM project. So that's kind of
right.
mostly source to target mapping with the logic here.
With
Uh,
across multiple systems. So someone could look at this document and say project category one. What we did is up here we put the if there was a query that this query has 2 tables, we put alias A, alias B here, and then what we did to simplify the notation is we just have A dot category one, A dot category two, right? And then here, this is our table for the retech data. And we have so it's just like a nice, easy place to go to say, hey, where are you getting this information from? Right. So we call that our data dictionary. And I'll go back and let you talk
yeah.
about the other things.
Okay.
Yeah.
Yeah. Modeling guidelines. So then also like in order to really kind of to have the same language for across like the entire team plus users. So everything the kind of modeling guideline and also there's like naming convention guidelines. So we kind of package this together. And those are really how you name the table, how you name the columns, what kind of data types you use, what the patterns you use, making sure that the things like really easy searchable and really patternized and really well understandable what it is. Because when you kind of look at the column, uh, which has like unknown names,
Mhm. Yeah.
this is like really hard to understand. So the more here the more data self-explanatory, metadata self-explanatory, the better will be for understanding. Also, it's much easier to work with
Yeah.
the
So I mean,
system.
three
So
three simple examples are if it's a date field, it's always got date underscore and then what it is. Date underscore invoice, date underscore order, date underscore purchase date, whatever, or purchase. Um, those we do that with dates. if it's any kind of dollar amount field, it always begins with amount underscore. Any kind of quantity field is quantity underscore, right? You can imagine all the variations that people do when you have like 5 or 6 people writing SQL and they're building out their own fact tables and all this stuff. Like things get like out of control really quickly. If it's a dimension, there's always like the code and a name, so it'll be like project underscore code or project underscore name, customer underscore code, customer underscore name, right? So these are like, if you're a lone developer building out a warehouse, you may not have to think about this, but in our situation, there were many people writing SQL, and it was uh, clear that we needed guidelines. Yeah.
Hey, James, so we
I
have
have a
hands up.
question.
So, go ahead, Gonzalo.
So this is Gonzalo. I have been a developer for many years. So one thing that I have noticed and that we never used was an attribute called description in SQL, in analysis services, in Power BI, for every attribute. Now that ChatGPT is here and AI is coming, prepare your databases, your semantic models with descriptions. Use that attribute so you can use it later.
Yeah. Yeah, inside semantic models, there's a concept, they're called synonyms. So like, yeah, that's another area where you can, if in a quantity field, you could call it QTY or you could call it units, and you can give all the aliases that someone doing a search might use. You do that in the semantic model and synonyms, and I think what you're saying in database, there's a description area where you can
Right. Every
enter
attribute
that metadata also.
has an option of description, but we have
Yeah.
never used it because the tools never
Right.
utilize it.
Right.
But now with
That's a good point.
AI, if you
Yeah.
capture a good description, the AI can understand and help you.
Yeah. Yeah.
Good,
Yeah. The
good,
yeah. Yeah. All right. We're
so
kind of
yeah, we'll quickly go through the rest of these. So there's a Teams channel. So we also like there's like, if you have like, use a Teams or use like, what use like some
Slack
other
or
tools
something.
like yeah, Slack or some other chat. It depends like what company is using. So that's kind of much easier to faster communicate rather than like emails there. So making sure that always kind of in communication, there is like, there is a Teams channel and there's like people put their like thoughts there, discussion there, status, planning, everything down there. Also, there's like POC semantic models. So those are really good. Inside the Fabric, you have a tool that actually gives you entity relation diagram easily. You can draw it there. So you don't need to have some other tools like that, kind of available tools for ERDs. But here, like you have, when you have like your tables, like in your Lakehouse, you can create a semantic model inside, and you can connect those, display how tables are connected, and that can be really good to show the rest of the team and to the users like how tables are connected, how they are modeled. That can serve also as the kind of visual element of the for the data modeling.
There are many things we're finding with the Fabric semantic model, though, is that you can only pull in information from one lakehouse, right? So a workaround is you can add shortcuts in that one lakehouse to other lakehouses. That's like a workaround. A cool thing we saw was that when you build Power BI reports, so if I have like 2 web pages open, if I have a Power BI, like a Fabric Power BI report open on the right and a web page, and I have the semantic model open on the left, when you add a measure on the left, it instantly shows up on the report on the right. So there's like a tight connection between the two that's really interesting. And then also, I mentioned earlier, like the direct lake data shows up in your table, it's in the report. But there's no Power Query, okay? And there's only pulling data from one lake house. And the UI is a little not fully there, so you got to use tabular editor. And something we've noticed also is that our reports that are off a Fabric semantic model, a lot of times they won't render. And to fix it, we have to open up the Fabric semantic model, refresh the schema, and then the reports work. And we don't currently know why that's happening, but it'll get there.
Okay.
All right, let's This we can kind of skip over. You talked about the guidelines already.
Yep.
We looked at this already, the source to target mapping. I could speak to this one, the sharing data. So, this security in Fabric's evolving. At a high level, there's like you can grant access at the workspace level. And I think I might have reversed these slides actually, the images. On the right side here, this is actually the workspace security. So there's admin, member, contributor, and viewer roles. But then this image is actually for a SQL endpoint. So you could like, on a particular lakehouse, you can, without giving any workspace access, you can grant access to a SQL endpoint. And you could even tell them whether they can write Spark queries against it or, regular SQL query. But yeah, and I would say something that we're doing is like we don't have every area modeled out yet, right? Like we have dozens of dimensions, dozens of facts. We don't have everything, and there's business things that need to happen. There's reports that need to go out. So with some of the BI members, we grant access to our if there's 3 layers, raw, stage, and model. Raw, forgetting about raw, but like stage is version data, right? It's like you can think of it as a mirror copy of whatever the most current data is out there. And we sometimes grant access to that, and we'll give them SQL endpoint access. They'll connect their Power BI report to a SQL endpoint and work with those tables. All right, I want to mention this driver worker pattern. This is a platform architect thing. This is something I've been doing for a while. I don't know if this is an official term for the pattern, but it definitely is a pattern. So the challenge is like, how do you parallelize workloads? And this can be done in pipelines, or it's something that comes up when you're working in pipelines or in notebooks. I have a note here about roles. The platform architect kind of builds this. The data engineer uses them. But in this pattern, the driver is what works needs to be performed. And the worker is something that performs a single unit of work. And so you have many layers in the architecture. You have a raw layer, stage layer, a model layer. Driver typically accepts a job config name, reads the job config tables and says, okay, you want to run the refresh customer order job? Okay, well, there's 15 data tables that we need to pull from SQL Server. So query runs, produces that list of 15 configuration details, and then you could iterate one by one and call the worker, or you could kick off in a batch at the same time 15 workers, right? So what this translates to, let me see, like, okay, here I have some names here, right? So like in Fabric, we might call this the PL for pipeline extract SQL driver, or we have a notebook NB extract HubSpot driver. And then we have a corresponding worker pipeline or a worker notebook, right? So this is where that like naming convention comes into play. If I just wanted to call one REST API for HubSpot, I could just do that in the worker. I give it the REST API name, and then it just does what it has to do. This screen is really small when I'm presenting here, but this is something to look into. What we found in first working with Fabric, we had a pipeline with a for each loop, and we unchecked the sequential box, and let's say we were kicking off 15 Fabric notebooks inside there. It was horrifically inefficient, and it would fail. And it would fail because we would run out of capacity, because every notebook that was kicking off was spinning up a new cluster, and we would run out of compute. Okay, so this thing right here, this one line of code, MS Spark Utils notebook run multiple, opened up a lot of doors, and you should read up on that. And it's what it is it's a way of executing multiple notebooks in Fabric in batches. So you could play around with the batch size. That's a configurable thing in our framework, but it's part of this driver worker pattern, and it's just a good way to think about like work in general, right? What do I have to do? That's the driver. Am I doing 5 things? Am I doing 20 things? And then having this worker pipeline or notebook that just does one unit of work, it processes one REST API or it processes one table, is great for debugging, right? Like you don't, yeah. So anyway, it's a pattern that we've been doing. This is an example of our workspace artifacts real quick. So I don't know, I went with LH at the end for Lakehouse, but really probably I would go with LH underscore whatever and LH underscore, but too little too late to change. But we have an audit Lakehouse. These are all of our auditing files and auditing tables. We have a config Lakehouse. These are all our configuration details. The layers are not sorted right here, but it's alphabetical, but like we have a raw layer. So the raw layer is all of our Lakehouse files, very organized structure. Stage layer reads those files, produces versioned tables of the data. Model is our dimensions and facts. You can see our driver worker pattern here, right, for each layer. So we have raw transform driver, raw transform worker. We have stage transform driver, stage transform worker, model transform driver, right? So those driver knows how to read our job framework, knows how to read all those tables to figure out what work needs to be done. And then we have pipelines, right? So this is our orchestration, basically. And you can see at the bottom, we come up with a run ID. We pass that run ID to each layer. So this pipeline executes all the raw stuff. This does all the stage stuff, all the model stuff. And then we have we can refresh semantic models here. But, minimal artifacts, right? Like we're supporting 4 or 5 like big systems, but it's all configuration based and we don't have a lot of artifacts. Each one of these artifacts does a lot of stuff, but they're generic, right? And that's what the architect brings to the table.